What are the metals in the reactivity series? Potassium, sodium, calcium, magnesium, aluminium. What's the non-metal here? Carbon, zinc, hydrogen, iron, copper, silver, gold. Okay? So, the higher it is, the more reactive. Okay, who can react with just normal water? No need to heat up nothing. Who can react with water? Sodium, potassium, calcium. Hello. Did you give the paper to Okay. So potassium, sodium, calcium all react with water. So potassium react water, become potassium hydroxide. And what gas will it release? Hydrogen. Okay, so sodium also same. Calcium also can react with water. Now this is just normal, plain, cold water. That's why they say cold water. It doesn't mean the water has to be cold. It just means the water doesn't have to be hot. Okay, so it will just react because it's very, very reactive. And then this one will bubble. Okay, can? Now, magnesium will react with steam. It's not reactive enough to react with just water. You have to react it with steam. What is the difference between steam and water? Steam is you heat it up until, yes, you heat it up until 100 degrees Celsius, so temperature is high. So when you react it with steam, you don't put it in water. These three form alkali. They form alkali because it's in water. Get it? That's why it's an alkali, it's an aqueous. But this one is not. This one is just steam in the form of gas. So this magnesium oxide and hydrogen. This one will still be a solid. Okay, can? Okay, below doesn't react with just water like that. Okay, can? Now, what about acid? Okay, so we take this same, so this one is with water lah. Okay, we talked about this last week, right? Last week. Oh yeah, last week all were not here. Yeah, you can. Okay, so I'm gonna do water. I'm gonna do water, acid, carbon, and then with each other. Okay, can? Okay, can. I'll send it to you later. Don't worry. Can. I'll send it to you later. I just discuss. Yeah, no matter. You can if you want to rewrite it, you can send. You can write it later. All right. So now part 2 is with acid. Can potassium, sodium, calcium react with acid? Of course. If you can react with water, of course it react with acid. But we don't usually put potassium and sodium in acid. Why? Kabu. We don't want to die. Okay? So basically, everybody above hydrogen. Now, why is iron here? In some books, you will see hydrogen below, iron on top. Because it depends. It's their reactivity is more or less the same. So actually, who cannot react with acid is these three. So even if you put hydrogen down here, it doesn't matter. It is the same thing. Okay. So who doesn't react with acid? Copper, silver, gold does not react with acid. We have done this. This is like the 5th time I'm telling you because remember the reaction acid and metal. Copper, silver, gold. They are too stable. They don't react. So they are non-reactive or inert metals. Okay. So remember when someone goes and clean the chain. Okay. For example, you know, the old uncle that wears the big chain, okay, or the guy who wants to be like the rap music one, all the big chains. Okay, every day they wear on their neck. Do you think it'll be dirty? Yeah, ugh, it's really dirty one. No, it's all the sweat. The neck not dirty, the chain become dirty. The gold chain will become dirty. So what happens is you bring it to the goldsmith, they can wash it for you. If you go to the goldsmith, you go to Pokong or whatever, right? You look at the gold, right? All shining one, bling bling. Why? Because they continuously wash it. What do they wash it with? They wash it with acid. So they take the chain, they dip it in acid. When it come out, bing, only the metal doesn't react. Okay? Our sweat, slightly acidic. That's why got the sour smell, but it doesn't corrode the chain. Not strong enough. It will corrode your skin first if it's that acidic. Now, what happens is if you go to the goldsmith shop, your mother takes the chain to go to the goldsmith shop and then put and wash and then dissolve. What does that mean? It's fake and your father is in trouble. Okay. So it means it's just normal fake gold. Fake gold is made from metal, iron. They just color it. They can color it gold. Okay, can? So what happens is acid. What do I mean by reactivity series? Okay, if I take the same volume of acid, same concentration of acid, so for example, sulfuric acid, okay, 10 centimeter cube, 0.1 mole per decimeter cube. Okay, and I put 1 gram of magnesium, 1 gram of zinc, 1 gram of iron. Okay, so hydrogen will have bloop, 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 bloop. Very reactive, very fast reaction. Zinc also bloop, 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 but not as fast as magnesium. Iron will react, yes, so bloop, 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 so you can see. If I put copper, no reaction. Okay, can? Now, using this logic, what happens if I put aluminium? Okay, so here's the special thing about aluminium. When you put aluminium, eh, wait yeah, it's special. You put the same acid, it will not react for a few minutes. For a few minutes, nothing. You wait, nothing. After that, only it will react. Why? Because aluminium has a special property. It forms a layer of, like, it's not like TV like that. Aluminium oxide. Yes. Okay, so how do you see it? Remember, it forms a layer of aluminium oxide. This aluminium oxide is like a protective layer. So because it has this layer, oxygen and water cannot go in. So it cannot rust further. It cannot corrode further. So that's why we can use aluminium to make aluminium foil and keep our food. It doesn't become rusty. It doesn't spoil. Rust is only for iron, but the other word for other metals is corrosion, corrode. Okay, so because it has a layer of aluminium oxide that prevents entry. But what if it's acid? Doesn't acid react with aluminium oxide? Yes, it does. So when the acid reacts with aluminium oxide, it has no hydrogen gas. Remember, what do you get? Aluminium chloride and water. Remember, you get water. So it will not, what do you call that? It will not bubble at first. Okay, because it is dissolving the aluminium oxide first and it forms water, so no bubbling. Once the aluminium oxide layer finish, then only it will start to bubble. Get it? Okay, so this is something special. Did you write this down already? No, yeah, okay, right. This part I think I haven't. This part I haven't. So wait, what? About the special thing about aluminium oxide. I talked about it in terms of corrosion, but not in terms of acid. Um, 2 AlCl3 because here's 6 one. Can see it or not? AlCl3 because Al is 3 plus, Cl is 1 negative. Okay, is it clear? Can see it or not? I can pick a bit. Sorry. Okay, ready? Okay, okay, okay. All right, Ken. Okay. Okay, now what happens here is that is for acid. Can? Okay, so we take the same reactivity series. Now we talk about with each other and also with carbon. Okay, so with each other, this is calcium, this is zinc. Okay, who is more reactive, calcium or zinc? So when I heat up, okay, this one, right, when it's solid, okay, guys, by now you must know what is solid, is aqueous. When I write acid, you must know it's aqueous lah. Okay, you cannot look at it, oh, I don't know. So if it's this one is heat up like that means you put in a crucible, like that. Okay? Mm. So you heat it up, put heat. Okay. Calcium is more reactive. Can calcium steal the oxygen? Yeah. Yeah. So you will get calcium oxide and zinc. Ta-da! Okay? Okay? So this is all solid. This is actually very useful. I taught you all about the thermite reaction, right? Thermite, that's no. Thermite reaction. I told you, right? I show you the video. No. Yes. The one very bright. No. Okay, so something else. Okay, wait. Yeah, I'll tell you in a while. I'll tell you in a while. Okay. Yeah. So basically, if I put copper and magnesium oxide and I heat together, will anything happen? Anything? No. Why? Because magnesium is more reactive. Magnesium already got oxygen. Copper say, please give me. Magnesium say, no way. Okay. Yes. I'm repeating the whole thing because I cannot just discuss question. He'll be lost. Yeah, okay. And anyway, y'all haven't come for class for so long. Okay, so and also last week we didn't have class, so just a review. Okay, get it? Understand? Okay, now what happens is uh the railway track, okay, no matter how high end your train tracks are still made from what? You still need what metal? It's the most important metal. Iron. Okay, steel, iron. Same lah. Iron, steel is 99%. So these kind of, especially the traditional ones, they're made from iron. Okay, let's say there's a crack. So how? So we have this really cool reaction called a thermite reaction. Yeah, it sounds a lot like the ants termite. It sounds the same, but it's not. Okay, so it's called a thermite reaction where I take aluminium and I burn it together with iron oxide. Okay. Now, when I heat this up together, is aluminium more reactive? Yeah, so it will become aluminium oxide and iron. But what you must understand is this reaction is very exothermic. So because it is very exothermic, it will melt it. Okay, I'm going to show you a video. This is how they fix it up. Okay, so that's a thermite reaction. So, okay, all right. So this one is so that when the iron is formed, uh, when the iron is formed, okay, the iron will go here and it will fix up whatever is broken. Get it? Okay, can? All right. So that is with each other. Okay, now there's another one called. Oh, sorry, you're right now. So there's another one called displacement. This is also displacement, but this is displacement with oxygen. Now we're going to talk about displacement with the metal and aqueous solution. Okay?
So actually the iron react the iron is melt down to form new iron to
Yeah, new iron to seal the space. Okay, can. All right. Yeah. All right. So can.
yeah.
Okay.
Previous problem.
Okay. So okay, what's the color of copper sulfate? Blue. Why? Because I'm coloring it blue. Okay. Okay. Now, who is more reactive? Magnesium or copper?
Magnesium.
So who is going to throw electron?
No more. Wait, copper.
No. The more reactive will throw electron or take electron.
Sure.
Oh,
Sure.
so magnesium really wants to become Mg2 plus. Really wants to throw electron. Now, if somebody throws electron, there must be somebody else to catch the electron, accept the electron. Who's going to accept now?
Copper.
Copper? Copper what?
So,
Copper ion. In copper sulfate, there is copper ion and sulfate ion. The copper ion, magnesium say, I want to react. Copper ion say, okay, I take for you, I hold for you. It's like magnesium wants to go swimming. Take out the outside t-shirt. For me, somebody hold for me. And copper say, okay, I hold for you, I wear. Get it? Okay, so you must have it like that. Okay, magnesium release electron. What kind of reaction is this?
oxidation.
Very good, oxidation. So this is oxidation. And this one is
Reduction.
reduction. Okay, remember that? So magnesium plus Cu2 plus become Mg2 plus Cu. What kind of equation is these two?
Half.
Half. This one is?
Full version.
No.
Wait, this.
It has ionic, so it's called
Iron.
ionic equation. And then the complete equation is,
Copy all the things.
yes, copy everything. Okay. Wow, I need a new pen. I don't know why it keeps doing that. Okay, so who displaces who? Magnesium displaces copper from copper sulfate. So from a blue solution, it becomes a colorless solution. Okay, that's your observation. That's what you see. And copper is a reddish brown deposit will start to form. Can you understand? That's it. So oxidation, reduction, ionic equation. These are half equations.
Does the copper fall to the bottom?
Yeah, of course. Sorry. The copper will form to the bottom, reddish brown, because it forms a solid like that.
Ah,
Okay?
yeah.
Okay. My nose is so stuffy. Alright, ready? So when you guys do your IG next year and you get enough to go to college, are you gonna finish from 5?
I am.
Huh?
My mother wants me to.
You're gonna do SPM?
Yeah.
Okay. Okay. Can?
Yeah.
Correct. You okay? Can. Alright, I want you to try these. If there's a reaction, I want you to write all the reactions. If there's no reactions, write no reaction. What?
So familiar.
Smell?
No, I mean the person.
Yeah, then you better know how to do. Sorry? Yeah, this is all displacement. These are all called displacement. Yes, everything. Yeah, everything. You all copy the question. I want to off this for a while and do something. Oh my god.
Yeah. Okay.
What? What?
And then he's asking who's rich enough to use gold for an experiment. So he said gold.
Yeah. Okay. Copy? Yes.
Okay.
Okay, give me a second. I just want to just. Yes. Got yeah, because iron is more reactive than copper. So Fe become Fe2 plus. Why cannot become 3 plus? 3 plus not so easy to react. From Fe2 plus, it cannot become 3 plus. If you have Fe3 plus, Fe3 plus can be, if you have Fe2 plus already, then you can oxidize it to Fe3 plus with another oxidizing agent. But if you just start with Fe, it becomes Fe2 plus first. Okay, can?
What is another oxidation?
Acidified potassium magnate 7. Remember? The purple one, purple to colorless.
Oh, no. Well, yeah.
Okay, so these two have equation,
Yeah.
Right, and then chemical equation.
Fe plus U
This is ionic, right?
Fe2 plus U.
What am I doing? Right. And this one, Fe plus.
U plus Fe that's
What's the color of iron 2?
blue.
Green.
What?
So this one, blue to green. Copper 2 is blue to green. And then you will also see copper, so you will see deposits. Get it? This one, is there a reaction? Yeah.
Yeah. Cu2 plus U.
Silver is 1 plus. Okay, that's where you see there's a difference. 2 plus and 1 plus. So 2 Ag plus.
是对的。Yeah.
Okay.
老师，我那个 reduction 也是两个负 AG 的。
So this one must put 2.
Oh.
Because it's CuNO3 2. Okay, and 2 Ag. Get it? So now it becomes from colorless to blue. And then the deposits are silver, right? So shiny gray deposits or silver deposits. So all of this is what reaction? This displacement. No, silver.
Silver.
No, this one is not bitter, it's aqueous mah. So the colorless solution becomes blue. Blue solution becomes green. This one deposits is reddish brown. There? Yeah. It's hot, right?
I am
It's very hot.
cold.
You are cold. Why? The aircon is facing you, is it?
I am mistake.
Oh, next time I must sit there. So hot here. Yeah, a little bit uncomfortable. Okay, understand? Do you guys understand? Got it? Okay? Alright. Alright. So that is displacement. Okay. Now, do these metals exist as pure metals in the soil? Of course not. They exist as
I thought three of them do.
yeah lah. Right. Okay. So potassium, sodium, calcium, magnesium generally exist as salts. Okay, so for example, potassium chloride, sodium chloride, calcium carbonate is what?
Eggshell.
Close.
Limestone.
Limestone.
Eggshell.
Calcium oxide is what?
Eggshell. Wait.
If this is limestone, this is lime.
Oh.
Okay, limestone, lime. And then if this is limestone, this is lime. And then this one called what?
Limestone.
Come on, come on, come on.
Lime water.
Very good. Lime water. Make sense now?
Yeah.
Limestone, lime water. So lime is not limau, ah. Okay, not limau in that case, not drinking. I know students very confused. Teacher, lime is base. But if the lime is sour, isn't it acidic? And then we're not talking about the same thing. Why they call it lime? People are stupid. I didn't name this one. Okay?
Wow. 这个呢是什么呀？
什么？
那个那我知道你那我是白色的。
什么？你在讲什么？吃的 lime 还是这个 lime？
这个
这个 lime 是粉笔啦。
哦，诶，
啊
哦，limestone，
，limestone 好像粉笔这样的。then 如果你 heat it right, it will become marble。那你拿来做桌子那种啊。
啊，喂，哦，这一个多话，那是
如果 you go up to Penang or Ipoh, right? Okay, then you drive up uh up north, right? You see the all the mountains, right? The mountains are like 白色的，你有看过吗？啊 It's not snow. Yeah, Malaysia got snow, got polar bear living there. It's all 白色的, see before or not? All white color.
I
You all next time go on road trip, don't look at phone, look at the surroundings.
where where
You go up Ipoh, you go up Penang, you go up if you go up the north south,
you know I've been
anyway.
almost many times by then oh 哦，香港的话，还有现在是那个里对，白的，
Yeah, it's worth high up. Okay.
Yes.
The first time I drove up Penang, my car couldn't move up. Then I was wondering, like I felt what's wrong with my car? Then I realized it's up the mountain. It's not up the mountain, but it's uphill. Where is this? Where did you guys go? Huh? Nepal? Oh, yes. How was your trip? Was so adventurous. Your parents want to go. Was so adventurous. Not your parents want to go there.
We and college. Yay. Teacher.
Yes, my dear. Yes.
那个 H 跟 F 也反过来的。He's asking if H
可以
跟
可以可以
可以反过来的，
可以。
因为我学校是都是反过来。
Yeah, can. So
Ask you what will happen.
okay, so you see, I show you before, right? Then where is my list?
What will happen if you react H and F? No.
No, no, sorry, it's iron hydrogen. Iron hydrogen. That's why I was wondering why. But actually, nothing happens. What happens is acid can react with hydrogen. Sorry, acid can react with iron.
Yeah.
Iron can also react with iron oxide can react with hydrogen gas. Can.
What?
So so this one is terbalik. Sorry. My bad. My bad. No mind lah. It doesn't make a difference. It really, really doesn't make a difference.
Our school puts it below zero.
Yeah. No. There's actually two kinds of hydrogen. There's actually other metals also. Wait, let me write first.
Other metal.
That means it's actually potassium, sodium, calcium, magnesium.
Which color? Sound. Oh.
So
None.
if you learn SPM, your hydrogen is here. But then your hydrogen can also be here. Actually,
Why is PB again?
Lead.
That's what instead.
No. You guys, listen. If you learn this is electrochemical series, then reactivity series actually carbon is here and hydrogen is here. There's two. So when it's hydrogen, it means it can react with hydrogen gas. When it's this hydrogen, it means it can react with acid. So there's actually two.
Hydrogen gas. Oh. Oh. Okay. Oh, maybe.
There's two kinds of reaction. When I put it here, I'm talking about acid. When I put it here, I'm talking about hydrogen gas. But for yours, don't stress. They won't ask you one. Okay. All right. Okay, let's focus on this.
So it was. So it was the end.
They're not going to ask you to write. No. Okay. Magnesium sulfate, magnesium chloride, so many different kinds of salts. Okay. Aluminium exists mainly as aluminium oxide. The name of this is called bauxite. This is the one you need to study. Okay.
Bauxite. They asked me to write a specific name uh for for what again?
Okay. Zinc. Last time you study the ore. It's ZNS, zinc sulfide. It's called zinc blende. But the blend is spelled with an E. Now it's not in your syllabus anymore. Yeah, blende. I also don't know why. Okay, so this is it. But it's not your syllabus anymore. Okay. Alright. Iron is your best friend. Iron and aluminium is what they ask always. Iron is Fe2O3. What is it known as? Hematite.
What about galena?
Yeah. Okay.
Yes.
The copper, galena, all that they don't ask. So your most important is these two. Your iron.
Galena also not iron. Yeah.
You learn it in science, right?
Yeah. Not very in depth, just the name.
Yeah, just the names, right? Sejarah also you learn. Why you think it's called Bijih Timah?
Oh.
Bijih means ore.
Timah is what? Tin.
Tin. Tin ore. Bijih besi. Get it not?
It also here
In sejarah book got sure got one. Yeah. Bijih Timah. Alright.
Everybody got to run it.
Okay, can Sorry, what?
Copper, silver, and gold.
Silver and gold exist as its element. Copper exists as galena, but you just heat it up in the air, it will react. It will become ore, become metal again. You don't need to extract. Okay, we need. Okay, so if let's say I have zinc oxide, let's say. Okay, I change the zinc sulfide to zinc oxide. I want to make it to zinc. Very easy. I burn with carbon. Can this happen?
Yeah.
Can. I have iron oxide. I burn with carbon.
Anything below carbon can be heat.
Can. Okay, but if I take aluminium and I burn with carbon, can? Get it? No, so yeah. So burn with magnesium. Okay, he said burn with magnesium. Can or not?
Yeah.
Can. But where are you going to get the magnesium from? Right, can. But where are you going to get the magnesium from?
Get from planet.
In the banana, it's not pure potassium, it's potassium salts, ions. Get it?
Oh, sure. If you want to get Manhattan responsibility, like 300 Manhattan.
Yeah, there's no way of getting potassium poisoning. Okay? Can? Alright, so those that are above carbon, in order to extract them from their ore, we use electrolysis. Electrolysis of molten or electrolysis of aqueous.
Aqueous. Oh, correct. Right.
Electrolysis of aqueous gives you hydrogen.
Oh, okay.
Get it? Remember not?
I think I do.
Never mind, we'll do it now.
Do. Then the realize me.
Okay, ready?
Wait, that's three electrolysis types, right? I forgot.
Are you
Just remembered this.
with graphite, with
Oh,
copper, and then there's molten and aqueous.
I'll just do one.
Okay. You don't talk about it now, very hard.
You answer wrong now. Oh,
What's that?
You're back. From back to the
You feel very
toe.
cold. Cold.
Wow.
That's the most fun. Yeah, for those. Okay. Someone you wear jacket. I'm so hot here, someone you wear jacket. Okay, guys, dearly beloved children, please write down the half equations for anode and cathode for both. Okay. And in
Plus E negative.
Cl, so this one is cation, and cation go to the cathode.
And K plus E negative become Na.
Anode is the Na.
We can't. We need a two. Okay.
F2, Cl2, Br2, I2, N2, O2, H2. Always must be 2. Okay?
Oh my.
Yeah.
Okay, then have to modify the oxygen part.
Okay. So you get sodium and chlorine. So this is how you make sodium in the industry by electrolysis of molten. Do you think it's an expensive process? Yes. Do you think it's an easy process? No. So you cannot burn. Wait. Okay, can? Okay, so aluminium. Do you get this correct?
Yeah, I know it. So 2 O2 negative become O2 plus 4 E negative. Yeah.
Okay.
Become Al2 plus OG.
Not Al2.
What?
2. 4 Al.
Oh my God.
Okay.
Okay, man.
Now, so imagine if this is the way we extracted aluminium in the industry. Do you think you'll have some problems? Yeah, because this is the cathode. Okay, this is the cathode. Do you think molten aluminium can just stick here? No, it will form here and then it will slide down. Right now. Okay. Now, here you will get oxygen. Is it possible for gas to be here and then molten aluminium to be here? Is it possible? No, it's very, very difficult because this is molten, It's like super, super hot. How hot? In order to melt it, it needs to be 2000 degrees Celsius. Do you think that's a good idea? Do you think it can reach 2000 degrees Celsius? But why must it be molten? Because if it's not molten, it cannot conduct electricity. Why can't it be aqueous? Because if it's aqueous, I won't get aluminium, I'll get hydrogen. Problems, problems. Okay. Another problem is when oxygen forms here, here is graphite. Graphite is carbon. It will react with the graphite carbon and form carbon dioxide, and my graphite will become smaller and smaller and smaller. More problems. Correct? Okay. Now, chemistry-wise, this is correct. Okay. Chemistry-wise, this is correct. But you cannot use this in the industry. So we modify it in the industry. How do we modify?
Change graph.
Yeah, we do a few things.
Fill in.
Platinum 是熔更快. Platinum is a metal. Okay, you finish? I want to draw the next.
Maksudnya kita harus ingat nih.
Huh?
Tidak dengan apa dengan sih. Wah, saya beri belum tahu. Belum beri.
All right. Man.
Wah,
Got it, got it.
ya.
Yeah. Now, we do transformer. We make the anode up. We flip the whole thing sideways. So here is the positive anode. So the whole thing is all anode. All three anode. Okay? And then cathode, we do down here like that.
This. 这会不会出现？
We flip sideways.
哦，
Okay? And then that is.
and where's the moon?
Wait lah, chill, chill. Wait.
Oh,
Okay, so here we put, instead of using molten aluminium oxide, we take cryolite. We melt the cryolite. Cryolite is a chemical. Instead of using water, we use cryolite. It's a chemical. When we take aluminium oxide and we dissolve in cryolite. Okay, so this is the most important thing that we do. We take aluminium oxide and we dissolve in cryolite. So now the temperature is 900 degrees Celsius. Now, if you learn SPM next time or you learn the old textbook, they will say lowers the melting point. But actually, it doesn't lower the melting point because the aluminium oxide doesn't melt. It dissolves. It's like water, acts like a solvent. Understand or not? Okay. No, it's exothermic, but it's the solvent. We still need to heat up the cryolite, but now we can reduce the temperature to 900. So at 900 degrees Celsius, the aluminium and oxide ions are freely moving. So cryolite does two things. Number one, it reduces the operating temperature. Now we don't need to do at 2000. And the second thing it does is it increases electrical conductivity. Why electrical conductivity? Because now the positive and negative ions are freely moving. So it increases electrical conductivity. Okay, get it? All right, so now aluminium, one problem solved. I reduced the temperature. Where will oxide go up or down? Hello? Anode, okay, thought oxide up. So you go up, all the oxides go up. When it goes up, it makes oxygen, so go out this way. Okay, but then remember this is graphite. Will it react with the graphite to form carbon dioxide? Yes, but it's okay. As this one becomes smaller, we just replace every few hours. We just replace this every few hours. Can you understand?
How to replace this? 900 degree.
谁叫你用手？用 machine.
No.
Look out! Use machine, replace, yeah, put back.
Imagine a human holding on to the ground there.
Aluminium go up or down?
Down.
Now it becomes molten aluminium. Aluminium go where? Go out here. Get it? Ta-da! I solved all my problems. Can you understand? Okay. Yes. Please copy this now.
那种上面有这些只在雕里面的啊
Yeah.
，not practical。
No, it's still the same thing. It's just that we move it around a bit.
Will this diagram appear in the papers?
Yes. It's in the papers that I gave you that you forgot to bring.
Okay.
Okay, ready? Or less 900 degrees Celsius.
Oh,
Yeah.
right.
Done? Okay, write this down. Let's do this part.
希望以后的我看，看不懂，以后的我看懂。对，好，现在的我看得懂，以后的我不一定。
Okay? Boleh? Do you understand?
Yeah.
Okay. So, blast furnace I taught you last week already, right?
Yeah.
Okay.
Show us the video you watch.
So, you guys can go home and finish the paper. The paper that day I only did, wait, I'll open the paper and show you.
I'm pretty sure Kaden already done it.
The blast furnace part. There.
He was trying to guilt trip you to reduce the money.
Okay.
是这样自己要讲。
What? Yeah. You know you exam all finish, 你要做什么？没有东西做了。
Actually started.
Okay. Now, so we last week. Okay, let's go through. So you understand how to extract aluminium now? Okay, so now let's go through. This one no need to copy. This one's last week's one. Remember how I told you about iron, how it rusts?
Yeah.
Okay, who is the gangster? Oxygen and water. As long as there's oxygen and water, they demand electron. So they are the gangster. Who's going to give the electron? Iron. Okay, iron will give the electron, water and oxygen will get the electron, and therefore it will corrode or rust. Okay, and so this is the formula for rust.
So write that about for the island. Like when I write the island, your island solution, the island, is there really be that?
Instead of rusting, is it? No. No, because I said rusting is only for iron. Corrosion is for all metals. The corrosion of iron is called rusting. Get it?
Why is one portion?
Corrosion also can, rusting also can. But if you want to write rusting is only for iron. Okay. And then we talked about how to prevent iron from rusting. You can either put it inside a layer of oil, okay,
Cover leaking.
electroplating, galvanizing. Remember what's galvanizing? Okay. And then we talked about what you call that? Sacrificial protection. If you and your mother go to McDonald's, your mother will pay, your mother will sacrifice. So you use a more reactive metal, you can use zinc or magnesium. Okay, can anybody use potassium? No, potassium too reactive.
It's so important.
Yeah, nothing nothing. Okay. So remember that, and then we talked about hematite. So last week we already did the reaction of hematite. The blast furnace is in the questions. Okay. So look at this. Okay. So last week we talked about extraction of iron, right? Do you remember?
Yeah.
Okay. So you're supposed to go home and finish all this. Now, because you have learned electrolysis of iron or aluminium oxide, you can also finish all the rest.
Okay.
Okay. Can okay. I wanna go through this with you all to remind you what we have done so far.
The